It was dark. Sorry, I remember.
All right, all you guys need for science today is a pencil. All you need is a pencil, and if you see anything on the desk nearby you, just leave it there, okay?
Put together,
That's amazing.
You use the
Here's
pencil.
the most polite ever. Just a gentleman who's so polite. It's amazing.
okay, how can we
Yeah.
let everyone know what it means to be
Yeah. He's big. He's the one that always opens the door and holds the door for you. Says good morning and good night. And that would be amazing.
parents that, or grandparents or whoever expects that, grew up with that, right?
Yeah. Yeah, for sure. Alaya. Dáselo a mami. Gracias. She just started with us today.
Who else are in the
She's
same?
been in the States for a couple months. So a little bit of English, which is also free, which is interesting.
Small group.
Yeah. It doesn't tell us what for. It's at the desk. Specific yet.
She's been in the elementary school.
She was at 10 from December to now. Very interesting.
Okay, so now I'm gonna have so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
I say that and
I guess that is everyone. Alright. Well, then we'll just have a small amount of people today. It'll be super fun. So we are going to be talking about forms of energy. Alright, so we're going to be talking about forms of energy. We did not have a lot of science last week, so I know that we might be a little bit fuzzy, but can someone tell me how many forms of energy they can remember? So we'll just let each person name one. Who can name a form of energy? You Q. Mechanical. What is mechanical energy? Moving, right? It's energy produced by movement. Does anyone else have anything they want to piggyback or add on to what Q said about mechanical energy? Andre? Sound energy? Yep, that's another type of sound. That's another type of energy. Let's go back to mechanical energy. Q said it's energy produced through movement. Natalia, what can you add on to that? Like a roller coaster. That's a great example of mechanical energy. Is it mechanical energy if the roller coaster is stationed in one spot, like when you get onto it and it's not moving? No. But when it starts moving, it produces that mechanical energy. Then Andre said sound energy. Someone tell me what they know about sound energy. Amy. It comes in waves. It travels in waves. What are those waves produced by? What produces sound? Remember when we stuck our hand to our vocal cords? Vibrations. Good job, Q. Vibrations create those sound waves. So that's another type of energy. What else can we remember? Jaden. What energy? Heat energy. Energy produced by changes in temperature, right? So if something changes a temp, that becomes heat energy. What else? There's a couple more that I can remember. Angie. Light energy. Energy that comes from light. And light, how does light energy travel? waves. Just like sound and light energy both travel through waves, right? We can't see the waves, but they travel through those invisible waves. And what's our last type? Friends, heat energy. We already said heat energy. Good thinking. What else can we remember? Natalia. Chemical? Yes, chemical energy is another type. We're not going to be investigating that one today, but that is a type of energy we talked about. What produces chemical energy? Here. That's another type, but what produces chemical energy? Remember, something happens. Andre.
When it's like something, either something burns,
Okay.
or something is changing into a new state or
Yes, and what do we call that? What's the broad category we call when like something happens because of chemical changes? It's a chemical
reaction.
yes. So chemical reactions, examples of those, Andre said, are burning, when something burns. When we have like a battery, that's chemical energy, right? Anytime we have a battery, that battery contains chemical substances, so they react. And what was the other example you said, Andre? You said burning, and when something changes substance, right? Like spoiling milk, rotting milk, that's a chemical reaction. And then Q said electrical energy. What do we know about electrical energy? How does it move, or what does it move through? What do you think, friends?
Through like wires.
Okay, a wire. A wire is an example of a
Mechanical.
not mechanical.
I don't know what's it called by.
It's a conductor. Does that sound familiar?
Is
Yeah.
that the conductor, the one that takes in the heat?
It can transfer heat, yes, when energy transfers. But a conductor is what electrical energy runs through. Okay? All right. Does anyone think they have anything else they need to add to our review about what we learned about energy? Okay. Let's talk about this. Can energy be created or destroyed?
No.
Give me a thumbs up if you say yes. Give me a thumbs down if you say no. Can energy be created or destroyed? So thumbs up for yes, thumbs down for no.
It can be destroyed. It just gets turned into a new type of energy.
Very good, Andre. You're such a good listener. Energy can't be created or destroyed, but it transforms. So we can't make energy and we can't destroy it, but we can take a form of energy and turn it into a different form. It transforms. Like if we were to plug in a lamp, when we plug it in, what kind of energy is that an example of?
Heat.
Electrical, because it's traveling through the conductor, which produces the light, which can produce the heat if that light stays on too long. It'll start getting hot and burning up. Okay, good job, guys. So, we're going to do an investigation. But first, let's talk about our expectations. How should we behave when we're doing an investigation? Someone raise a quiet hand and give me an example of a behavior we should see when we're doing an investigation. Natalia. Focus. I love that one. That's good. We should be focused. We don't need to get distracted, right? We don't need to be looking at this group and seeing what they're doing because they'll all get to do everything. So we need to be focused with our group because we're going to be working in pairs. What is another expectation we should have when we're doing an investigation? Cute. Communication. I love that one. So you should be talking with your group, right? You need to be participating because is it fair if one person's doing all the work and the other person's just standing there? That's not really fair to the other person, right? We need to be doing equal amounts of work. We need to be helping.
Or like if there's only one part, we can each take turns doing it.
Yes, exactly. That's a great example of participation. So this person can do this part of the project, and the other person can do the other half. That's a great example. Or you can do it all together. You guys get to work that out yourselves. What is another expectation we need to follow that you guys can think of? What if there are instructions? What do we need to do with instructions? Follow them, right? Each set will have an instruction sheet, and you can read through it. We need to follow them so that we make sure the experiment goes correct. What about listening? Right? right? We always need to have listening ears on and be hearing the teacher or hearing out a partner, being respectful to them. Anything else we need to add on? What do you think, Jake? Memorize? Memorize what? Remember the expectations? Yes, exactly. We need to remember the rules and follow them. Okay. You guys are killing it today. So, here are your instructions. I'm going to split you off into groups, and you're going to work with your group to follow the instructions at each station. Each station will have an instruction sheet. This is what it looks like. So you read through it, and then you follow. And then each station also has a piece of paper with some questions on it, okay? And then you'll also have your materials. So you have your instructions, your questions, and your materials. You will answer the investigation questions on a separate piece of paper. So each group needs to have one person grab a piece of paper, and they will record the answers, okay? Because they only have one paper for each station, so not everyone can get one of those. So you're going to do it on a piece of notebook paper. And then we're going to share afterwards, and we'll go over that later. Does that make sense? Give me a thumbs up if you think you understand what we're doing and you're ready to go. Okay. All right, let me split you guys into groups. Let's do Prince and Skyly. Stand up. And go to that back table. And then let's do Amy and Angie. You guys can stand at that station. Let's do Quishana and Jaden. You guys go to that one with the plastic bags. Then Andre and Olivia, you guys can be at the back where Austin usually sits. And then you three can be here. And then Natalia, you can join Olivia and Andre. Yeah, that looks good. So each group needs to have a piece of paper. Do we have that? Okay. Show me with your fingers how many minutes you think you would want to do the project, which would only take a couple minutes. It should be really quick. And then answer the question. Show me with your fingers how many minutes you think you might need. 10, 15. Okay. We'll start off with 10, and then if you guys need more time, we can do more. Yep, you can start.
Our baby's absent today. One, two, three, 4, 5, and one more than 1, 6.
Got it?
Only 22 students?
Yeah. You get it? Okay, perfect.
And then we have some that we switched within the
So
home.
you do it with the marble. Record what happened. And then you switch out the marker for the block. So let's do the question. I have something really quick to add on. Everyone will look over at me. What's a good strategy to do before we do the investigation? It's the same thing we do with reading. Read the questions, because some of them want us to predict things, right? So I would read through the questions and then do your investigation. And then, yeah, you switch the marker out with this the second time. Okay, does that make sense? Okay. Did it light up?
No, it's already up.
So if it doesn't light up, let's think about what would happen if it didn't light up. That's technically what it's supposed to do. It is being a little bit tricky. So keep trying. If it doesn't work, think about what would happen if it did, or maybe what would happen. You can also mark those down on paper.
This one, these are the phones, right?
She does that. We come from the single, come over here. I'll hold it. You see the rainbow? Good thought process. I like it. She sees it? Did you get it? I've tried it like 4 different times, 4 different lights. I'll tell you what I was. It seems like the first time you see it on there, it would work, and then it would work for like 2 seconds, and then it would stop. And I think that was the so you guys are the right now. Or you could put down like a clipboard, and then put it down with the
Ready for this rest day? Honesty, so I have to be honest.
do it right on the. No, you're right on that.
Why?
Because I did a couple like right here, and then she not put it right the back to the back. Like it went down the cup, and it also do the cup radius in a marble
Well, you guys say that time. If you need to redo it, I'll redo it. When you guys just set it back how you found it. I promise I won't break it. I did it myself. Just hold it for a few seconds. You'll feel the heat. It's not that sweet. You saw a rainbow without the light? Why do you think you saw the rainbow without the light? But what would be reflecting? You know rainbow is light. So there's other types of light in the room, right? Good observation. Going good? Yeah. Okay.
I forgot to do that.
I only have one of these pictures. Did I return the set of my house? Did it have a lot of these? Really fast, and then just keep going. And I'll give you more time. Don't stress me.
10 more minutes.
I'm thinking, here, this is what I'm doing. It's hard to do this. I did good. Oh, was your hand? Oh, what? By holding that? So like I used this battery for one day. I did it and it lit up, but then it stopped working. And then I used this battery and it lit up, and then it stopped working. So I'm thinking you can only use it once. I'm thinking, why would you only be able to use it once? Maybe it's sucking all the energy out, right? They could be a little bit more powerful because it's a big battery, but maybe it's causing us to use a lot. energy. That's what sucks it all out. And I got to work 2 times out of like 250 times.
You ruined this experiment for us, Michaela.
You haven't even been through the rest of the stations, Andre. Sassy Andre. Show me with your fingers how many more minutes do you think you might need? We're doing 5 more moments. Okay, giving me more time. So let's do 5. We only need 1 paper. Does that make sense? So she'll take the paper and write all of this down on her paper. Can you erase the top when she has it? Because other groups need to use this. Eventually, I need all of them.
So you can't. So you
This is
can't
the
write
questions, but that is the test.
Oh,
This is like the test sheet, and you record your answers on this, right? For like that. Right. And that's okay. I'll give you guys additional time if you need it. Just, that's okay. It's mistakes happen. It's not a big deal. So just write that down in there and then erase it so that other groups can do it, okay? Okay. If it doesn't work, just make sure you start recording your answers, whatever your answer needs to be. There's not a set number. This is whatever your brain is thinking, you're recording. And also, does that make sense? Like everyone needs to follow these questions and only have 1 paper question. So put these on there and then erase it. Thanks, buddy. What do you think is going to happen?
Because the height is like more higher, but the marker was like little.
Right. What did that one crack? Did it move more? No, it only like. Let's compare. Let's compare looking at the cup now that we know what's on it.
It moved a little.
A little more, right?
The marker got because it rolled down fast. When it gets up, it's moving up.
Mechanical. So we're thinking about mechanical energy. Or how that's higher. Think on that thought. See what you can come up with. Okay, I want to get through all the stations, so even if you're not done with your question set, that's totally fine. I need everyone to freeze, set things kind of up how you found them. Jane, erase that 1 paper really good, so I can't see. So freeze wherever you are, set your station back up how you found it, and then I want us to move this way. So you guys will go where Jane and Quashana are. Jane and Quashana will go to the back. You guys move there.
Wait, what if you're not doing it? That's okay. That's okay. If you can't read. Oh, that was cool. Place the cup over the end of the roller. Did we take this one out? It should touch the back of the cup. Marker.
Make sure you follow the directions on that one. We're gonna swap this out for
Wait, this can't tell. When it goes down, it goes like this. It goes like this. Do it.
do it really fast.
That sounded really
Don't do it again. Yeah, we don't work good.
Do you need batteries?
They got one.
What size battery?
Marble hit the
Thank you. That should be good.
How much room? Think about everything. If you had stuff, why? To them, what do we know about why? With energy. And what they are.
Where were you, Jonathan?
Okay?
All right, go see Miss Campbell. See which group she wants you to join. Here. He's another amazing one.
Different from higher we use the block of a marker. The roller
He is racing. She's doing an amazing job with him.
For number one, what do we, for 10, what do we other cabins? It would turn off, okay. So why do you think that happened? Push number two. Why do you think that would turn off? What kind of, and how does that? What was it first, before, yeah, light energy? Well, let's think about even both, we'll go with that. What kind of energy would you have? Just a plain battery. chemical? You said mechanical? That's moving.
Is it chemical?
It would be chemical. Anytime we have a flame of batteries, that's chemical energy right there. Because there's stuff inside this battery that causes things to light up or move or cool down, right? So that was a chemical reaction. That was chemical. And then what happens? We start the prong on it. Turn it into light. And what else? What other kind? We have wires. What do we know about wires? What do we know about wires?
Wait, level station 1?
The conductor. What do you know about wires? What is a conductor? That plugs out in our bin. I'm plugging the wire into the wall. If I take a lamp cord, if I plug it, or no, that's not the lamp cord, that's the sharpener. If I plug in the pencil sharpener, the wires into the wall, it says, you see a little spark sometimes when you plug something in? Electrical. I said mechanical. Because I asked you if you said electrical, and you said mechanical.
Everything. Yes. Exactly. A whole different level.
What do we hear?
So it doesn't matter how many years you teach or when you get to different.
Doing a great job of asking questions.
Right?
Just going up and saying, okay, good job. Oh yeah, you're on the right track. And ask questions at every single
Solid, liquid, and nothing like
That is done. Can you set that back on my back? You
that.
Are you guys done? Okay, you guys can go ahead and pull your stuff for that station, set it, reset it up, and then switch. Keep going this way. It's okay if you didn't get all the questions done.
Cute to see the groups that Mateo, you guys are here.
You ready? But this is also been used like 3 times now. So what do you think of this out? Whatever, he said. Okay, leave those there. Answer the question. So again, how about I just have and see what to say. And it's supposed to light up. Around some kind of flip it. Okay. So for 10 that lights up, and don't hold up there. So it's not lighting up, it'll get hot. So, yes, right? So for 10 then it worked. Or you can look at it from the angle of why it didn't work. And then answer the question. I will tell you that I did this at home, and I'm thinking that each battery can only be used once because it works for a split second when I put it on that one and then it stopped working. Then I tried it on the other battery, and for a split second it worked and then it stopped working. So I'm thinking that it only works once. Why do you think that would happen? It has to be cold. Do you think it's the temperature? Maybe. What do we think about related to energy? How much energy it has? Did I use it all up? How about it? You guys are done with your question? Yeah, like, let's see what else. Yeah. You tell me like some detail in your answers. My other groups don't even, they're taking their time. More time. You want to stay focused. What are we seeing? Remember the times of light I'm like, it's not reflection. Fraction. Does that sound familiar? So refraction was when the pencil went into the water and it fit, right? So what do you think happens when we hold this up to light? Let's see. So you saw that. Now when you hold it up to each other and you see 3D, that would be not refraction, but Reflection, writing about it. All right, let's freeze. Set your station back up, and then rotate. And if you're not done, it's okay. Set your station back up and flip, please.
Why she got it on video?
Let's flip. Come on, flip station. We hope you guys just want to get started. Nope, it goes. This is the. This is supposed to be. Let's read the directions. Okay. We have solid, liquid. This is air, so it's gas. Right? Predict which vacuum will produce the loudest, medium, and softest sound. Place the Ziploc bag with water next to your ear, lightly tap with your eraser right at the pencil. Listen to the sound. And you repeat. So follow the instructions. Station 5. Okay. I don't hear anything. So, this is like that. So let's think about number one, why it didn't. Two, let's think about what if it did. And what I'll tell you that I did it at home, and it worked each time when I did it. I placed it on here once and it worked, and then it stopped working. And then I placed it on here once and it stopped working. So think about why that means. You guys understand? Then you switch out the marker with the block for the second time. Go free, gas.
Sir,
Look who this.
are you gonna look real handsome? Cool, right? What did you notice?
First upside down. Like one time we look, it looks up in the sky, then it looks
Why
down.
do you think it's doing that upside down?
Because the light
What's happening with the light?
is refracting.
Yes. High five. High five. Good word. Good word. What else did you notice?
They crossed the rainbow.
Yeah.
And actually, these look like them things you would see on somebody's desk that would have their name imprinted on it.
Yeah.
They're so smart.
Other way around.
This group overall is very science smart. Like science course I've never been this really. Yeah. Yeah, it's exciting.
Have they had exposure and opportunity to play around with science throughout their time here?
They have not in the classroom, but we have the STEM lab and we have the WAS lab. WAS is it's a lab that was donated by what's his name, Wozniak.
Okay.
Yeah, he donated a whole lab, like everything. Furniture, it's everything. It's amazing. That's the WAS lab. So we do a lot of science there, and she does a lot of piggyback on the standards. So, yeah. STEM. We have STEM each one. It's one of our special rotations. Yeah. And it's making a huge.
So do everyone also take science plus the STEM?
Just fifth grade. Seventh grade.
Okay.
The other grade levels incorporated with reading, but they don't really do science.
Reading is important.
Yeah. So we're lucky that we have those two, which is 45 minutes for each class a week. So we're getting 90 minutes of science.
Which is too bad it's not every day, but it might end up being more. If it's a pull-out, as opposed to I only have 30 minutes here or there, or 15 minutes.
Yeah. And I think it's kindergarten.
It's okay if you didn't get very far, but I want us to all have an opportunity for every station
But they are
to
getting
do
90
a last
minutes
flip.
every week.
A last switch. Set everything back up and switch to the next table. For my son's toys. But it's a solid block. But I did it at home, and I set it on the first battery, and it worked for like a split second, and then I switched to the other battery just to try it again, and it worked for a split second with that battery, but then it stopped. So why do you think that may have happened? Think about it as you answer your question. I put it on the first battery and it worked. And I put it on the second battery and it worked, but then it stopped.
Science kits that I think were purchased in 2002 or something like that. Finally, in 2018. I mean, every classroom has a huge 15 gallon or whatever, filled with whatever was appropriate for their grade level. And after it was 2018, the district, we're going to move in a different direction because they were going to replace the fourth grade rocks for the rock cycle. And there's different types of rocks to replace all of those rocks. Just for example, in second grade, there was a lot about the water cycle and replacing different bobbers, and we're going to go in a different direction. We just thought that was so funny. They don't hear for years. You were having to do your experiments with things that didn't work.
Yeah.
Because they were so old.
Or missing pieces.
Oh,
Hundreds. Yeah.
exactly.
Or those kids. Because I remember we did once a week after science training. want consumable stuff. I don't want to feel like, okay, next year. Right. I want to move an apartment or house, so. No, right. What now? Right.
If I use this battery for a couple seconds and it works, and it stops, and I use that one, what normally happens if you like watch TV on the
That's fine.
Just take the battery, the energy got sucked out of the battery when I used it the first time. Maybe you don't end up getting wired.
It was coming down fast. Maybe I could have went up to mechanical. What is that?
Why did it suck it all out?
Why they sound
They put it like that.
there are different states.
I'm thinking that I sucked all the energy out.
Okay, well,
I didn't want to know that.
Jonathan, I was wondering why you were coming over here. I didn't see a roll this way.
Question. Which one do you think has the most fiber? She answered that one. Why?
So. Well, wherever we enter.
2 minutes to wrap up, okay? 2 minutes to wrap up.
I dare you go without water. You have to ask them, they didn't want the dust. I dare you. And story for water for them.
You guys put out your water bottles before?
I was telling the only thing out of your angels are little future inventor. So I'm sad that he's not here because I was
I did a question for 1, 2, and 3.
Perfect. Take care.
I wonder the battery one again. Either my fingers still have it.
It's not hitting up anymore. It's not hitting up anymore.
I don't like a burn from this one.
What do you use? Use all the energy. Use the energy from both the.
Yeah, why can't you use that battery?
Once it's got in, those vitamins like that, but
You said the energy was stayed in the battery?
yeah, it's
So how did the energy leave the battery?
because when I put this in, it came through the wire and it came out with it. Alright, I need you to leave everything where it is and go back to your seat. Your normal, everyday seat. I can take your pictures. You don't need them for this part. Thank you. Alright, once you guys are seated, we'll go into the very last part of today. Jonathan's ready, Natalia's ready, Mateo's ready, Eva's ready. Thanks, Prince, for cleaning up. But that's okay, I'll get it later. I want to get to our sharing part. You can help me clean later. Let's have a seat. Okay. So we're going to do what's called a snowball share, okay? So I want you to find a partner and sticky high five them. That means this. Sticky high five me, Krishana. You high five them and you don't let go. Okay? So find a person that you can do that with that wasn't in your group. It wasn't in your group. You can get up. I have one group of. You're responsible. Okay. You guys ready? Once you have your sticky high five, eyes on me. Okay. You're gonna talk to that person and you're gonna tell them what you observed. It could be an ending station, it could be questions you have. If you have a question about why this worked, or if one of the questions on the table confused you and you need to explain, maybe that person can help you. So go ahead and talk for like 5 minutes, share what you discussed, and then we'll go to the next question.
Honestly, how long did it take you to get all of the kids? Everyone's talking about what they're 50. Not talking about the weekend, recess, lunch. I mean, that's, because it's so hard for information to understand how to get to this stuff. Because even when they're in the classroom or in the office, just grasping everything that you're doing is very hard. And one of the questions that always comes up is, how long do you think it took you to get?
So I have to be honest with you. For the great team that we have right now, she was the first year, and they are amazing. Did a great job with the kids. So yes, we still have that.
I love this.
In the other two classrooms, there's still a lot of staff that we have to things for the whole day. But to me, you know,
Okay. You and your group, or your partner, that you get five, need to partner up with another group of 2 kids. So find another group and partner up with them.
What else?
They join them, so you guys join Lucasia's group. And then, you guys going over there? You're responsible. Alright, share with them even more. Or what you're going to talk about. Wait, who's the voice? Right here, friends. I already know what you guys are thinking. Do not do that at home.
I am.
No, you're not about to do it at home. That's big. I should not brought that.
I'm gonna make phone calls.
Yes.
I'm gonna make phone calls.
We're gonna post on Dojo, but you guys do not need to do that.
Or better yet, you know what? Go ahead and try it, and then we'll laugh. We'll have a little laugh.
Okay, how many home is selling us, right?
Right.
It will burn your hand. Seriously? Alright, we did it for 10 seconds.
I wonder if you like put
I know, but I would not.
a water bottle with foil and like heat matches right there behind the foil, would it like heat or would it stay the same?
That's a great question.
That is a really good question.
Because you have the water right there and the fire right there. and the foil right there. And if it heats up, it's like chemical or mechanical.
The foil heating up,
Yeah.
is it gonna change the foil?
If it's just heating up, dude, it's still physical. It has to burn for it.
Well, if it's heating up, Andre, if it's heating up, which one is it?
Just heat. It's about chemical or physical. Or
It's thermal, right? It's heat energy, right? To be chemical, what needs to happen?
For it to burn or change to a new substance.
Change, correct.
That's one of the things we did in the fourth grade. We didn't have to show we had an adult in every group and they used the foil that was supposed to and salt and then put sugar.
Oh,
It was
so they can see it melting through the heat transfer.
yeah.
Okay. So that is everything for today. Tell me on a scale of 1 to 5, 1 being like, and 5 being like, great, amazing. How much did you like the activity? So I know what you guys like for the future.
I broke the record.
This gives me a 10.
I bet even more record.
That makes me happy. Okay, so
I
you
got
guys like
11.
doing that? That was fun?
20.
Okay. Alright, it's pretty much time for lunch, so make sure you clean up, and then you guys can line up for lunch. Clean up means pushing all the chairs on the floor.